Now, what I said the other week was sine squared A plus cos squared A equals 1. It's a pick any angle you want. Do sine 30 squared plus cos 30 squared. It doesn't matter what angle you pick. Once it's the same angle twice, it will always equal 1. No matter what angle you pick. Are we good with that? So, next thing you're going to notice is the word sec. S-E-C and A. Now what secant means is sec A means 1 divided by cos A. Alright you guys? That's all it means. Now, what we're going to do to both sides here is we're going to divide both sides by cos squared. Okay? So we're going to end up with sine squared A over cos squared A. We're going to end up with cos squared A over cos squared A. And then I'm going to end up with 1 over cos squared A. And finally, 2 of them cancel, give you 1. Sine squared A over cos squared A is, anybody? Tan squared A, right, that's no big deal there. You got your 1. And what's 1 over cos squared A? The same as. And there you go. Yeah, that's it. It's handy enough proof. It's going to be very easy for you down the line. Next thing. A projectile P is projected from a point P on a horizontal plane with initial speed 35 meters per second and angle alpha to the plane. It strikes a small target which has a displacement of 350. Then, please remember what Connor said the other day. If it strikes the target, that's its time of flight, because it isn't going any further, is it? So time of flight now has a new definition because it hits the target. It doesn't just miss the target, it actually hits the target. Okay? So, in this case, what we're going to do is find 2 possible values of tan alpha and find the time of flight in each case. No bother, easy money. Alright, so phi x equals u cos A. So what's that going to be? 35 root 5. Cos alpha, cool with that. Phi y. 35 root 5 sine alpha. And please remember your GT. Xx. 35 root 5 t cos alpha. Sy. 35 root 5 t sine alpha minus a half t squared. Okay. Now, right, that's that part done there. Okay. So, Sx equals 350. At the same time, Sy equals 210. Those 2 times are identical. The easier equation is Sx. So I would work with Sx first and Sy second. Okay? So I'm going to get my Sx equation here. And that's going to equal it to 350. And then what I'm going to do next is isolate the t value. So t equals 350 divided by 35 root 5 cos alpha. What does that break down to? 10 over root 5, is it? 350 divided by 35 root 5. 2 root 5. Okay. So 2 root 5 over cos A is your t value or time of flight value. Now, the next thing we're going to do here is we are going to put this value into Sy. Why are we going to put it into Sy? Because we know that Sy equals 210 at this time here. This time causes the Sy equation to equal 210. We're going to plug it in. So we're going to get Sy equals 35 root 5 t, which is 2 root 5 over cos A. And then after that, minus a half g. Now, t squared. Yep. 2 root 5 cos A. And that all equals what is it? 210. Alright, let's figure out where we're going from here. 35 root 5, that's 70 times 5. I think it's 350 over cos A. Keep a close eye on it, please, and just check as we go along. Now, I'm going to change g into 4.9. A half g into 4.9. Yeah, I made a mistake, right? Where is it? Oh, the sine A. Yeah, thank you. Thanks very much. Now, next part is 4.9 multiplied by 2 root 5 squared. 98, that's nice, that's a good number. 98 over cos squared A. And then I'll bring the 210 over. Now, any suggestions? What have we done a couple of times at this stage? This part here and this part here, what we're going to do? Yeah, so 350 tan A minus 98 times 1 plus tan squared A minus your 210 equals 0. And then what we should get then is we should get minus 98 tan squared A plus 350 tan A. And what's it? 210 minus 98 is minus 308. I'm going to divide both sides by minus 7. See if we can break it down any further. Yeah, 14 for this one. Minus 50 for this one. And 308 divided by 7. 44. It'll break down further as well, which is handy to know. And then I'm going to divide it by 2. And I'm going to get 7 tan squared A minus 25 tan A plus 22. 0. 7 times 22 is 144. I can break it up into 144. This thing's quite handy if you ever want to get fractions. Go shift, factorize. So I can use 18. You can use any, see the way it's 2 to the power 4 and 2 to the power 4, 3 to the power 2. I can use any combination of those numbers I want. So I can use 2 by 2 by 3 if I want. I know 18 is a factor. In fact, it's 18, 144 divided by 18. 8, 18 and 8, would that work? Nope. Did anybody get a decimal answer for this? Do I have to use the minus b? You have to use the minus b? Alright. Well, somebody say me, did anybody get it right? Can you just give me the answer for the minus b then? What's tan A? 2 and? Alright, that means there was actual factors of that. Alright, fair enough. Minus b is easier. So 2 and 11 over 7. Now, when you go back to your time of flight, what function is in your time of flight? Cos, isn't it? So how would you find out what cos is for both of them? What's a good way of doing it without having to round off any angle decimals or stuff like that? Anybody know? That's 2 and 1 and that's A, so what's the hypotenuse? Huh? The hypotenuse will be root 5, won't it? 2 squared plus 1 squared. So what does that mean about cos A? of cos A in this case then? 1 over 5. And for the second one, it's 11 for the opposite, 7 for the adjacent. 121 plus 49 is root 170, I think. Yeah, square root of 170. Yeah, just root 170. Nothing can be done there. And this will mean cos A is 7 over root 170. Root 5 over cos A. So time of flight in each case is 2 root 5 over cos A. So that means one of them will be 2 root 5 over 1 divided by root 5. And the other one will be 2 root 5 divided by 7 over root 170. Do you have the answer for the two of them?
10 seconds.
10 seconds and? 8.33, yeah, recurring, yeah, no bother. So 10 seconds is your first answer for the time of flight, and 8.33 is your second answer. Okay. A bird flies over a tree exactly 4.6 meters directly above a hunter's gun and flies at a constant speed of 28 meters per second in a horizontal direction. If the speed of the bullets from the gun is 35 meters per second and the gun is fired just as the bird is leaving the tree, show that the angle of projection must be tan inverse 3 or 4 if the bullet is to hit the bird. Alright, so you want to draw yourself a quick diagram. Okay. This one represents the bird. Blue for some reason. We'll give it a beak. Alright, there you go. Now, this bird is going this way. Ever go with that? Now, what's the general shape of a projectile? It's an N-shaped quadratic function. Would you agree with that? Now, there's a problem. The problem is, can anybody tell me what does the Vx have to be? What does the Vx have to be to make this work? It has to be the same as well. It has to be the same as the bird. Why does your Vx have to be 28? Because if this is your bullet and that's your bird, what does the bullet have to do with the bird? It has to stay directly underneath it. At any given time, the bullet has to be directly underneath the bird. And what's the only way that will happen? If the Vx's are identical. Okay? If the Vx's are not identical, then the bullet won't hit the bird. The bird will be long gone, and then the bullet will just intercept the path of the bird, actually not hitting the bird. Okay? So that gives us a very precious piece of information. Okay? So the piece of information that will give us is that Vx is 28, and we know that this is 35, don't we? So using Pythagoras' theorem, what can we say then? 35 squared minus 28 squared is 441. Square root of 441, and you get 21. So you have 21 for the opposite. So then you can say that tan of your angle of projection, tan A, equals 21 over 28, which is 3/4, which is what we're looking for. If you really want to be thorough, you can say A equals tan inverse 3 over 4. Now, because I know what tan A is, I also have access to cos A and sin A. Cos A will be 28 over 35, which is 4/5. And sin A will be 3/5. Now, okay. Next thing we need to do is I need to set up my equations. So we're going to do phi x. Phi x is 28. Phi y is 21. We're going to change g into 9.8. Sx is 28t. Sy is 21t minus a half gt squared, so 4.9 t squared. Alright, can anybody suggest what do I do next? Sy will equal 5.6 because we know the bullet hits the bird at a height of 5.6 above ground. What we don't know, however, is what the Sx is. The Sx is a relatively unknown quantity. So we know the blue value, but we do not know the green value. Okay. So what we're going to do is we're going to put Sy equal to 5.6. I'm going to multiply both sides by 10. I'm going to get rid of the fractions. Then I'm going to divide both sides by 7. Then I'm going to move them all over to one side. Alright, 7 times 8 is 56. 56 needs two factors that give me 30. Minus 2 minus 28. Right, 70 squared minus 28t 2t plus 8 equals 0. 7t into t minus 4. 7t plus 2 and t minus 4. Okay, you guys? Yeah. 4.9 divided by 7. Oh, sorry. See that? I multiplied both sides by 10. So it actually turned into 49. So the 4.9 turned into 49, the 21 turned to 210, and the 5.6 turned to 56. And then I divided both sides by 7. So I think I'm okay. I'd be surprised if I made a mistake and the factors came out that cleanly. It'd be highly unusual. Did you get that as your answer? So t equals 4 and 7t equals 2, t equals 2 over 7. Perfect. Which value are you going to take? The first value or the second value? First value, because the bird you presume is pretty much destroyed upon the first impact. Okay? So, what we're going to get next is... Alright, done. Question is done. Right. Question 14 is next, is it? Next request. Alrighty. A bullet is fired from a gun fixed at point O with speed vms and angle theta to the horizontal. At the instant of firing, a moving target is 10 meters below O and is traveling with constant speed 42 root 2 at a constant angle 45 degrees to the horizontal. The bullet and the target move at the same speed. Ouch. That's a hard one to explain, isn't it? So, draw a picture. Visualize the question in your head. Let's just start off with the moving target. So, what I'm thinking of drawing a 45-degree line. I'm then thinking about a target like so. The circle will do the trick. Now, it's vertically above. So, my fault. I'll just extend the axis down. That makes sense? Right. So this guy moves up in this direction here, and what should happen is your projectile motion should eventually hit it and come back down again, and you're done. So what we're hoping is that, am I missing part of the question? If V equals 70, show that if the bullet is hit the target, then tan theta will be 4 over 3. Alright, so that's good to know. V equals 70, prove that the tan of the angle is 4 over 3. Right, happy days. Now, first thing we're going to do is we're going to use that 45 degrees and we're going to break it down into its components. Okay? So this is 70. So this in turn would be 70 cos A and 70 sin A. I'm sorry, 70 cos 45 and 70 sin 45, which are both the same values. So let's find out. I'm not talking about the bullet. I'm talking about the target. Oh, sorry. Sorry, the V value of the bullet is 70, is it? Yeah, you're right. I misread it. Oh, sorry. Speed of the bullet V. My fault. So, the bullet will be, we don't need to worry about the bullet angle for a minute. Yeah, thank you for that. It's 42 root 2. Yeah? And that's 45 degrees. So it's 42 root 2 cos 45 and 42 root 2 sin 45. Is that okay? Now what's 42 root 2 cos 45? Just 42, isn't it? And then the other one's also 42 as well. So that's handy to know. Now what does that mean about the bullet relative to the target? The bullet has to match it with a Vx of, Vx of 42 has to happen. Okay? And the reason why the Vx of 42 has to happen is the same reason. If the bullet is blue and the target is the circle, the bullet has to remain underneath the target all the way along. The bullet has to be at the same Sx value every single time. And the only way that happens is with the same Vx value. Okay? So now we have Vx equals 40. No. We have Vx equals 42. We know the bullet is fired at 70, don't we? So what value do I have there? I have cos A equals 42 over 70, which is exactly 3 over 5. Okay? Now, using Pythagoras' theorem, you can find out what the other side is. So you can do 70 squared minus 42 squared. Square root the answer, 56. So what does that mean about sin A then? 56 divided by 70, which will be 405. And finally, tan A, which is what you're looking for, is 56 over 42, which is actually 4 over 3. And that's what you're looking to prove, wasn't it? You're looking to prove that the angle of projection was 4 over 3, which it is. Find out at what time after firing does the bullet strike the target and calculate the horizontal distance of the bullet from O. Okay. Let's do what we always do. Set up our 4 equations. Phi equals 42. Phi 56 minus 9.8 E. Sx, anybody? Sy? 56T. minus a half, so minus 4.9 squared. Is that okay? So, that is your four formulas. Now, any other piece of information I haven't seen yet? Yes and no. Oh, I see the problem. Do we know the SY value when they hit contact each other? This is not 10. Why is it not 10? Why is that not 10? Where they hit each other? It's 10 altitude, hasn't it? Now, what we're going to do is we're going to find out what height do they actually hit each other at. Okay? So to find out what height they actually hit each other at, we're going to use an equation, okay? So, would you agree that every second it gains 42 meters in height? How do I know that? The target. It's going 42 across and 42 up. Would you agree with that? So, what we can say is that the target's height is going to be, the SY value is going to be 10 meters it starts off with, plus 42 multiplied by the time it's moving. That makes sense? So SY equals 10 plus 42, T. It could be any value, I don't know. If it travels for 1 second, it's 52 meters in the air. So we'll figure that out later, right? So SY equals 10 plus 42 T. So now we know what our SY is. SY is 10 plus 42 T. And what happens to the two SY equations? This one here and this one here. They equal each other. So it's no big deal. So 10 plus 42 T equals 56 T minus 4.9 T squared. Move everything over to the other side, we get 4.9 T squared minus 14 T plus 10. Don't like decimals, so we're going to do 49 T squared minus 140 T plus 100. It appears we're going to have to do the minus B for this. So, has anybody done this minus B yet? Do you have it? Thanks. What's the answer for the minus B? 10 over 7, and the second answer if there was one. Perfect square, is it? First answer. Alright. Do the minus B formula, get 10 over 7. You alright with that? Thanks. Okay. Now, what we're going to do next, lads, is we proved that it's 10 over 7. At what time after firing the bullet does the target, and calculate the horizontal distance of the bullet from O. Alright, that's not so bad. Alright. So T value is 10 over 7. That's the answer for the first part. And the answer for the second part is how far from its original horizontal position does it travel? That's an SX question all day long. So SX equals 42 times 10 over 7. You get 60 meters. There you go. That's what the book says. Cool. Happy days. And